Hey guys, I hope you've been working on your open review questions for your final exam review. We're going to go over those 6 questions really quickly. You will have the same number of questions and very similar questions on your final. So I'm hoping that you are getting comfortable with these. If not, make sure you write down the correct way to do them. We're just going to take a few minutes here and go through each of them. This first problem, you're solving an equation with radicals. We've been practicing a lot of these lately. We want to get this radical all by itself. So the first thing that we'll do is get rid of the negative 5 by adding 5 to both sides. We'll get 3 equals the square root of p plus 11. So now we have the radical by itself. What do we want to do? That's right, we want to square both sides. We're going to square both sides, and we have 9 equals p plus 11. And we will simply subtract the 11 and get p equals negative 2. Now we want to check to make sure that is the correct solution. And I will require that you do this on your final as well. So we'll take p equals negative 2 and we'll plug it back into the equation for p. So we've got negative 2 equals negative 5 plus the square root of, we're plugging p equals negative 2 back into the equation, plus 11. So negative 2 equals negative 5 plus the square root of 9, or 3. Negative 5 plus 3 should equal negative 2, and it does. Fortunately, negative 2 is negative 5 plus 3. So we know that that is the correct solution. That is what will be required of you on one of your final exam problems. Make sure that you know how to do that, solving it, and checking your solution. Let's go on to number 2. Here's one that we've also been practicing, where you're trying to take a linear equation that is in standard form, and I'm asking you to write it in slope-intercept form. So we're going to take 3x minus 5y equals negative 10, and we're writing it in y equals mx plus b form. That means we have to get y all by itself. Got to get rid of everything else except for the y. So we're going to get rid of the 3x, subtracting 3x from both sides. That gives us negative 5. That's all that's left over, equals negative 3x minus 10. We're writing that x term first because we want it in mx plus b form. Now we just have to get rid of the negative 5 to get y by itself. So we'll divide both sides by negative 5. Over here on the right, when we divide by negative 5, we've got to divide both terms by negative 5. We've got y equals negative 3 divided by negative 5 is just 3/5. So we've got 3/5 x. Negative 10 divided by negative 5 is plus 2. Here is our slope-intercept form of the equation. Now I've asked you to identify 2 things. The slope. Slope comes first. 3/5, not 3/5 x. 3/5. So we have a slope of 3 over 5. We also have the y-intercept of 2. You need to identify both of those things. Y-intercept equals 2. You're going to have to identify both of those things. That's in the directions. Make sure that you do both of those things on your exam, or you will not get full credit. Now, when we go to graph it, where do we start? Where do we always start? The y-intercept. We start at 2. 2 is our y-intercept. So now, we're going to use the slope to tell us where to go from the y-intercept. Our slope is 3 over 5, so we're going to go up 3, 1, 2, 3, and over 5. That's our next point. If we want to get a point going the other way, we're just going to go down 3 and backwards 5. So there is our next point. The last thing you'll need to do is connect these 2 points with a line. You should have a line that goes through your points, and that is how you would graph this equation. You will need several different things on your paper on your final exam, so make sure you have all of these on your review. You need to convert from the standard form of the equation to the slope-intercept form. You need to identify the slope. You need to identify the y-intercept, and let me know that you're sure which is which. Don't just circle things in the equation. That's not identifying. Write down what the slope equals and what the y-intercept equals. Finally, graph your equation. Start with your y-intercept and use your slope. to get some other points. Number 3, let's look at that one. We have our first word problem. You can read it on your paper. It's pretty small up here, so we could fit it all. We're going 840 miles to Mexico City, one of my favorite places, and back. The trip there is with the wind, so the wind is pushing against us on the trip there. We're going 840 miles. Nobody gets extra credit for that, I caught it. On the way back, the wind is against us. So we're also going 840 miles. This time, however, instead of taking 10 hours like it did on the way there, it takes twice as long, 20 hours. So it's asking us to find the speed of the plane. I'm going to call that P, speed of the plane, and also the speed of the wind. I'm going to call that W, speed of the wind. So we've got P is the speed of the plane, W is the speed of the wind. It's asking us for speed. But we don't have speed here. We have the number of miles we went and the number of hours that it took us. So we have to figure out the speed we were going on the way there and the speed we were going on the way back. That's going to allow us to find the speed. So on the way there, we're going how many miles per hour? We just divide. 840 divided by 10, or 84 miles per hour. That's kind of a slow plane, but that's how fast we were going. On the way back, we're going a little bit slower because the wind is against us. So 840 divided by 20, that's 42 miles per hour. Now we have speed, and we can figure out the speed of the plane and the speed of the wind. We have to write a system of equations. You need to write 2 equations, one for the way there, one for the way back. If you're going 84 miles per hour, that's the plane with the wind blowing behind it. What kind of equation could we write for that? That's just P plus W, the plane plus the wind working together, gives us 84 miles per hour. Now on the way back, the wind is working against the plane. So it's P minus W equals 42. The plane is flying this way, but the wind is pushing against it and slowing it down. We have to subtract. Now we're just going to use one of our methods for solving systems of equations. We should probably use elimination. If we add these, we can do that because these are opposites. The W's are opposites. Or we can subtract because the P's are the same. Remember, when your variables are the same, you can subtract. When they're opposites, we can add. I'm going to add the second equation to the first equation. That gives us 2P. The W's cancel each other out. Equals, let's see, 6 and 12. 126. Now we'll just divide by 2. And we get P, the speed of the plane, equals 63 miles per hour. If we plug that back into one of our equations, like right here, we can subtract 63 from 84 and get that the wind speed is 21 miles an hour. It also works in the second equation. 63 minus 21 gives us 42. So we have that the plane speed is 63 and the wind speed is 21. Remember, when you're solving a word problem, we want to give our answer in words. All right, so the way that you would properly write your solution here is to say the plane is going 63 miles per hour, or you could say the speed of the plane is 63 miles per hour, and you could say the wind is blowing at 21 miles per hour. If you have the option to take this plane to Mexico City, you might be better off driving. That's a long trip, especially at 63 miles an hour. Let's look at number 4. We're adding and subtracting radicals. We have to simplify each radical before we can add and subtract, because we can only combine like radicals. So we'll simplify the square root of 8 as root 4 root 2. The square root of 4 is just 2. So we have 2 times 2, or 4, times the square root of 2. That's how we would simplify this first one. Now we're subtracting the square root of 18, which is the square root of 9, times the square root of 2, or we're subtracting 3 root 2. We've got 4 root 2 minus 3 root 2. We'll simplify that in a second. Next, we're simplifying. Minus 3 times the square root of 45, which is the square root of 9 times the square root of 5. Well, the square root of 9 is just 3. So we've got negative 3 times 3 times the square root of 5. That's minus 9 times the square root of 5. And then lastly, we have plus 3 times the square root of 20, which is the square root of 4 times the square root of 5. Since the square root of 4 is just 2, we've got 3 times 2 times the square root of 5, or plus 6. 3 times 2 is 6 times the square root of 5. Now notice our like terms. We have 2 root 2 terms and 2 root 5 terms. So we'll just combine those guys. 4 root 2 minus 3 root 2 is just root 2. Or you could say 1 root 2 if you wanted to. Negative 9 root 5 plus 6 root 5 is minus 3 root 5. We've combined our like radicals, root 5s and root 2s, and now we're finished. Number 5 is an inequality. No equal sign, inequality sign. So we want to graph the line and then figure out which side of the line our solutions go on. So we're going to first put this into slope-intercept form. We want to get the x term on the other side of the equation, so we'll subtract 4x. And we get 5y is greater than negative 4x plus 10. Next, we have to divide both sides by 5. When we do that, we get that y is greater than negative 4/5 x plus 2. This is the boundary for our inequality. Now remember, if you were to divide by a negative right here, you would switch this sign. Whenever we multiply or divide by a negative, we flip this sign. But since it's a positive 5, we just leave it. Y is greater than negative 4/5x plus 2. To graph our boundary, we start with our y-intercept of 2, and then we're just going to use our slope, negative 4/5. We'll go down 4/5. We could also go up 4 and backwards 5. Now we need to ask ourselves, what type of a boundary line are we going to have here? Dotted or solid? If we have an equal sign here, like greater than or equal to or less than or equal to, it's going to be a solid line that says that line is part of the solution. But if we just have greater than or just have less than, remember, we're going to use a dotted line. So we're going to make this a dotted line right here for our boundary. Clean that up a little bit. There we go. There's our boundary line. Now we need to decide which side of the boundary our solutions lie on. So we're going to test a point. I'm going to test 0, 0. And see if it makes our inequality true. If I put 0, 0 in here, I get 0 is greater than 10. We all know that's not true. So 0, 0 is not a solution to this inequality. That means the points below this boundary are not solutions. So we're going to go with the points above the boundary. And that also checks out with the fact that y has to be greater than our boundary line, above the boundary. So we've checked it 2 different ways, and we know that our boundary lies above our line. And so we'll shade this area above the line. You don't have to shade it quite like that. You just have to show that your boundaries are above the line. So there we go. Find your boundary. That's going to be your line. And then test a point and figure out where do we shade it. Don't forget solid line if you have the equal to, dotted line if you don't. Last question. We're trying to solve for x in this triangle. Remember, the big thing here is the sum of the angles in a triangle equals 180 degrees. So we have 3 angles. We're simply going to add them together to get 180. So we'll say x plus 71 plus x plus 51 plus 80 equals 180. You want to write an equation to show how you're solving for x right here. So we combine like terms. We've got 71 plus 51, that's 122, plus 80, that's 202. And then we have x plus x, that's 2x. 2x plus 202 equals 180. Now, if we want to solve this for x, we're just solving this basic equation. We'll subtract 202 from each side. And we've got 2x equals negative 22. And when we divide by 2 to solve that equation, we get that x is negative 11. Now, if you want to check that, just plug that back into our triangle and make sure it works. Negative 11, negative 11. That gives us 40 degrees right here and 60 degrees right there. 40 plus 60 plus 80 gives us 180 degrees.